All right, today we're going to talk about chapter P.7 here. And here is your bell work. Hopefully you have attempted that. If not, feel free to pause the video at any time if you want to kind of work through the problems. Okay, so this one here's got 4 terms, so we want to look at factor by grouping on this. So we're going to factor out x to the 6th here. So we have x to the 3rd minus 1 left there. So we need x to the 3rd minus 1. So we're going to factor out a minus 1 on this one. So we have x to the 3rd minus 1 there. Okay, and then we have x to the 3rd minus 1, and then x to the 6th minus 1. And this x to the 6th minus 1 we just saw on the gallery walk that we did in class. But we also have a difference of squares here with the x to the 3rd minus 1, or difference of cubes, I'm sorry, here. So we're going to say x and then a 1, and then we have x squared, x, and 1. And the signs are the same, opposite, and add. Now, when we do the difference of squares on this one first, we always want to do difference of squares before sum or difference of cubes. So I noticed that this is a difference of squares. So that's x to the 3rd plus 1, x to the 3rd minus 1, which we had x to the 3rd minus 1 right here. So we actually have this twice. So instead of rewriting that, I can just write this as squared and squared and get rid of that term. And then I obviously need to do the sum of cubes here. So x plus 1, x squared minus x plus 1. And then you have your x minus 1 squared, x squared plus x plus 1 squared. Okay, so in this one, we actually have 2, 3, 4, 5, 6 factors. 6 factors in that whole thing. Okay, so be comfortable with grouping, difference of squares, and sum and difference of cubes. Okay, so in P.7 here, we're talking about rational expressions. And rational is just a fancy word for fractions. So we're looking at expressions that have like x or a variable as a fraction on the bottom. So our goal here is to simplify rational expressions using factoring and restricting the domains. So if we kind of look back here at the domain restrictions, there are a couple things that we want to keep in mind that you've talked about already in a previous class. Number 1 is if x is in the denominator, then that cannot equal 0. Okay, you cannot have 0 in the bottom. So if that's the case, this whole thing cannot equal 0. For example, if I have 1 over x plus 3, okay, x plus 3 cannot equal 0. Therefore, x could not equal negative 3 because negative 3 would make that 0. Okay, if we have a radical, I can't have negative numbers under the radical. So in this case, x has to be greater than or equal to 0. It can be 0 because the square root of 0 is 0, but it has to be bigger than that. It cannot be a negative number. And then if we combine the two here, Okay, just remember that the square root has to be bigger than or equal to 0, but I can't have a 0 down here, so we actually get rid of that equal sign. And we will use these facts as we go into restricting the domains of expressions. So if we look at these 3 problems here, we want to look at restricting the domains. Okay, this first one is just a polynomial. Okay, and it's actually just a quadratic. It's a parabola. So when we have that, there are no bad values to put in there for x. Okay, I can choose any number I want for x. So when it says find the domains of the following expressions, here x can be anything. So if we do set builder or set notation, we'd say x such that x is an element of the reals. It can be any real number. And I'm not quite sure how the author of the book wants it, but that's how we can write it. Here, remember the bottom cannot equal 0. I don't care about the top right now because it's just x and that's fine, but the bottom cannot equal 0. So I'm going to take this and I'm going to factor it. So I need factors of 6 that add to 5. So that's 2 and 3. It's end of the same, both negative. So x minus 2, x minus 3 cannot equal 0. Well, if x is 2 or 3, that would give you 0. So x cannot be 2 or 3. So I can have anything else except 2 and 3. So we could say x such that x does not equal 2, 3. And that would be your set. Some authors would want you to put in that it's all reals except 2 and 3. But I'm okay with writing just not equal 2 and 3. Okay, here we're combining a few things. Okay, remember here under the square root, it has to be bigger than or equal to 0. Okay, so from this part, x has to be greater than or equal to 0. But this cannot equal 0. And what makes that equal 0 is 5. So x cannot be 5. So if we kind of look at this graphically, okay, here at the top, I said x is greater than or equal to 0. So here's 0. Greater than or equal to is this way. But then we have 5, and we actually can't have 5, so I'd have an open circle here. Okay, so I need to build a set that represents this. So we could say x such that x is greater than or equal to 0, x does not equal 5. You could write it like that. Interval would probably be the best interval notation here. So 0 to 5, parenthesis, union 5 to infinity. And I know we haven't talked about that a lot, but you should have had it in a previous class of Algebra 2. So we can write that either way, but we have to make sure that we get rid of that 5 value. Okay, simplifying, that ends kind of the domain restriction. Now we're going to get into simplifying and kind of some operations. But simplifying, in order to simplify, you have to factor everything out. Okay, I cannot cancel these x squareds here because of this addition and subtraction. The only time I can cancel is if they are factors, meaning it's multiplication. So we're going to factor the top. That's a difference of squares. So we have x plus 1 x minus 1 over factors of 2 that subtract a 1. That'd be 2 and 1. Signs are different. The bigger one is positive. Okay, so here we can also put in our domain restriction. Remember, the bottom cannot equal 0. So what makes that equal 0 is x being -2 and 1. So that's what x cannot equal. But now I can take this and I can cancel the like terms and say x plus 1 over x plus 2 with my domain restriction. It's important that you get that domain restriction in there so that we have an idea of what the original problem was. This 1 went away when I canceled, but I still need it for the original problem. Okay, so when you simplify, make sure you factor everything. Look for GCF. Look for those special properties. Maybe you got to do the AC method, okay? Factor things all the way out. Okay, perform the indicated operation. So we're going to look at multiplying and dividing here real quick. And with multiplying and dividing it, it's pretty similar. Okay, and again, we're dealing with just fractions. So in order to multiply fractions, you multiply straight across. However, the first thing I want to do is I want to factor everything. You want to factor everything, okay? And you can just kind of write above and below it what the factors are. So like this one, we're just going to factor out a 3, and you get x plus 4. Factors of 3 that subtracted 2. 3 and 1, x. Signs are different. The bigger one's positive, so plus, minus, x minus 1. Factors of 16 that add to 8 are 4 and 4. Signs are the same. They're both positive. Okay, that's a perfect square trinomial, actually, right there. Okay, when I do the operation now, in order to multiply fractions, so step 2 was operation. Okay, when I multiply fractions, all I do is multiply straight across. Okay, nothing crazy happens. Okay, you just combine everything together. Step 3, we're going to look at domain. You could actually look at domain before and after the operation, especially with division, we'll look at next. Okay, so on the bottom, we look at on the bottom, x cannot be -4 and 1. Okay, so that's my list. I could add to that list as we go along, but you're never going to get rid of numbers on that list. So now that I multiply, I just go through and cancel. So an x plus 4, x plus 4, x minus 1, x minus 1. So you have 3x plus 3 over x plus 4. And you're done with your domain restriction. Okay, and that's not a J in between there, that's a semicolon to kind of separate the two things. Okay, division is very similar. We're going to start with the same steps. We're going to factor everything first. Okay, so this is factored. Factors of 4 that subtract a 3. 4 and 1, signs are different. The bigger one's negative, so plus 1 and minus 4. Factors of 6 that add to 5. Signs are the same. They're both positive, so x plus 2, x plus 3. This is a difference of squares here, so x plus 2, x minus 2. Okay, so that's factoring. We can look at domain restrictions here. So x cannot be -2, 2, and -3. Again, we're looking at just the denominators here. Now, in order to divide fractions, we multiply by the reciprocal. So we're going to keep the original. Okay, this went away though, and we factored all those. So you're going to keep the original. So you have x minus 4 over x plus 2, x minus 2. And you're going to multiply by the reciprocal. So you're going to flip the second one over. And then x plus 1, x minus 4. And re-look at your domain. Are there any more numbers to add? Well, this is new on the bottom. So we're going to add a -1 and a 4. Because that's now on the bottom and I can't have 0 on the bottom. Those two numbers would make it 0. In order to multiply fractions, I multiply straight across. And now I can cancel. +2 plus 2. X minus 4, x minus 4. It looks like we get x plus 3 over x minus 2, x plus 1 with your domain restrictions. Okay, so fairly simple on the addition and multiplication there. Just make sure you understand how to factor and how to look at the domain restrictions. All right, adding and subtracting gets tricky. Okay, in order to add or subtract, we have to have a common denominator. The easiest way to find the common denominator, well, number one, you need to factor. Number two, you're going to find the common denominator, which is the least common denominator, or the least common multiple on the bottom. And then number three, you're going to do domain restriction. And then you can look at the operation. Okay, so if we look at this first one, the bottoms are not the same, and I need to get them that way. So in order to get them to be the same, I just multiply them by each other. That's the easiest way. Well, if I multiply the bottom here by x minus 1, this has to get multiplied by x minus 1. And this one over here needs the x plus 2, so the top also gets the x plus 2. Okay, we're going to kind of cover up B for a second. We'll come down here with A. And you can distribute this 3 in here. So you get 3x plus 6 plus, and then distribute this x in here, x squared minus x, all over, and you're going to leave the denominator factored out. Okay, I said look at domain. Well, again, in the bottom, you can't have 0, so that means x cannot be -2 and 1. In the top here, I need to kind of combine like terms and reorganize. So you have x squared, 3x minus x is plus 2x, and then you have plus 6 all over x plus 2, x minus 1. Factors of 6 that add to 2, I don't think there are any. Factors of 6 are 1 and 6, which add to 7, and 2 and 3, which add to 5. So you want to relook to see if you can factor that, but if not, that's it, plus your domain restriction. Okay, now on B, we can factor first. Okay, here we didn't have to factor, but here we need to factor. This is x plus 1, x minus 1. Now this is x plus 1 squared, so that's x plus 1, x plus 1. Now, you should notice that each of them already have an x plus 1. So I don't need to multiply by that. But this one over here does not have an x minus 1. So I got to multiply by that x minus 1. And notice this is a negative. So when I distribute that, that's a negative 2. Now this one had 2 x plus 1s. This one only had 1. So it needs another one in the bottom and the top. Okay, if I come over here, B, we have x plus 1 minus 2x plus 2. I distributed that negative 2 all over x plus 1, x plus 1, x minus 1. You can get your domain restriction right here. So x cannot equal plus minus 1. Okay, and because they showed up twice, you don't have to do anything special. It's still just minus 1. Okay, see if we can combine like terms in the top. So you get negative x plus 3 over x plus 1 squared, x minus 1. Nothing I can factor out there. So we're going to leave it like that with our domain restrictions. Okay, that should be enough information right now for you to do the first day's lesson. So if you want to stop now and do the first day's homework, you can do that. If you want to continue, you can continue, but I suggest maybe stopping and looking at that day 1 assignment, and then this video you can come back to later to view. Okay, if you didn't get to all the problems on the first day, that's fine. Remember, the due date is the day of the test. So now we're going to look at some complex fractions. Complex fractions are fractions within other fractions. And they're pretty easy to work with if you know how to work with fractions. Okay, so our goal here is to work with the smaller fractions first and then end up with one fraction. Okay, so here I have x over y plus 1. Well, I want a fraction over here, but I need the denominator to be y. Well, instead of writing 1, I'm going to write y over y because y over y is 1. But down here, my denominator is x, so I'm going to write x over x, and x over x is still 1. So I'm going to add these in the top. So you get x plus y over y. You don't add those together, you just keep it. And then x minus y over x. There's kind of a shortcut here when doing these problems, and that's outers over your inners. Okay, it's still multiplying by the reciprocal, but when they're stacked up like this, you're going to take your outside 2 and multiply. So x plus y over your inners. So y times x minus y. We can see here that nothing is going to cancel. So then that is your answer. So make sure you find common denominators. You're going to get one fraction on the bottom, one on the top, and then do your outers over inner. You could, if you wanted, you could say x plus y over y times x over x minus y. Multiply by that reciprocal. That's the same thing. If you notice, we get the same answer. So I don't care which way you do it. Okay, here's another one to simplify. You notice in the top that I have an a plus h and an a. I can't just add an h here to the top and the bottom. Okay, I actually have to multiply this side by a, not 9, an a, And we're going to multiply the top by a. But then I have to multiply this one by a plus h. There. And the h on the bottom here, we can treat that as h over 1. So that I have a fraction over a fraction. Okay, so if I kind of do the operation here on the top, I have a minus h. You have to distribute that negative into both. Over a plus h, over h over 1. Okay, so a minus a goes away. We're going to take our outers, which is h times 1, so that's h, over your inners. So a plus h. Your h's here cancel. So you get 1 over a plus h. It's tricky. Make sure you find a common denominator. Make sure you distribute the negative when you need to. Make sure you have a fraction divided by another fraction, outers over inners. And this is where it gets tricky. Okay, so we're gonna combining a few things here. Okay, so we're just simplifying, but we need to factor. Okay, this is a sum of squares. We can't factor that. But if I look here, I've got 1 plus x squared and a 1 plus x squared. I got a negative exponent and a positive exponent. So in the top, when I factor that out, I can factor out 1 plus x squared. And I want the smallest exponent, so minus a half. So when I take that out, that minus a half, we subtract. Okay, so you have a half minus negative a half, which is addition. So you just have a 1. So you have 1 plus x squared to the first. Okay, because you factor that out, you subtract it. If you want to use u substitution here, you can, to make things, I don't know, look a little bit easier. You could say u to the half minus x squared, u to the negative half over u. Okay, u equals 1 plus x squared. And I don't know if that might be easier for you, but we're still just factoring out u to the minus half. It's still going to be over u. But this half minus a negative half is 1. So you get u to the first minus x squared. And this u to the negative half went away. So you just get that. And up here, we have it to the first power minus x squared, all over 1 plus x squared. Now, it's kind of easier to look at it on this side maybe, because I can cancel some of these u's. Actually, this negative half can come down here. Oh, I don't want blue. I'm going to use green. So u to the half, change that negative to positive, and you add those exponents. So you have u minus x squared in the top over, this is 2 over 2, so u to the 3 halves. Now we can plug u back in. If we go up here to this one, this is to the first, so it doesn't matter. The parentheses don't matter. I have x squared minus x squared, which cancels. So you have a 1. Well, this is all that's left. So 1 times that just stays that. So you have x 1 plus x squared to the negative half over 1 plus x squared. We can move that to the bottom, move that whole thing kind of to the bottom, and we have 1 over 1 plus x squared to the first, and this is 1 plus x squared to the half, because it became positive, and there's where we get our 3 halves. So 1 over 1 plus x squared to 3 halves. But over here, we still have to plug the u in. Here, instead of writing u, I'm going to write 1 plus x squared. You can see your x squareds are going to cancel there. You're left with the 1, and you have 1 plus x squared there to the 3 halves. So you get the exact same thing. Okay? Doesn't matter which way you do it. Okay? Doesn't matter to me. You're going to end up with the same answer, and this is totally simplified. Okay, that's a hard one. Okay, I'm not going to lie. That's probably a level 4 type question. Okay, one of the last things we want to talk about is rationalizing. We can rationalize either the numerator or the denominator. We rationalize the denominator more than the numerator. But the process of rationalizing is just getting the radical off the bottom. And we talked about these with simple radicals not too long ago. But in order to get this radical off the bottom, you're going to multiply by the conjugate. And we've talked about conjugate, so that's 1 minus radical 2. So 1 minus radical 2. And in the top, when I multiply that by 1, that's what I get. I get 1 minus radical 2. In the bottom, because they're conjugates, your middle terms cancel out. So all you have to do is the first and the last. So that's 1 minus square root of 2 times square root of 2 is 2. And 1 minus 2 is negative 1. So you could leave it like this, or you could divide everything by negative 1 and get negative 1 plus radical 2. This here is the preferred answer because we don't like putting 1s on the bottom. Okay, so it's all about getting that radical off the bottom. Now, here they want us to rationalize the numerator. Okay, this is the numerator. They want us to get the radical off the top. If I get it off the top, I'm going to put it to the bottom. So in order to do that, you can use u substitution here if you want to make it smaller. But you're going to take this times the conjugate, which is radical 4 plus h plus 2. In the bottom, radical 4 plus h plus 2. So in the top, you just need to do the first and the last. Okay, so radical 4 plus h times radical 4 plus h is 4 plus h. Negative 2 times negative 2, that's minus 4. So your 4s are going to cancel there. And here we're going to just distribute that h. Well, actually, let's hold on just a second. If I leave that h out, I get the square root of 4 plus h plus 2. Okay, so these h's now cancel out because you have an h over h times this quantity. So you have 1 over radical 4 plus h plus 2. And you're done. Okay, very similar to what we started with. Okay, you're multiplying by the conjugate. When you rationalize, you multiply by the conjugate. Here are some properties that have very common errors. On the left, you'll notice a bunch of addition or a bunch of multiplication and division. It's all multiplication and division. On the right side, where our common errors are, we have addition and or what could be subtraction. Okay? The rules of multiplication do not apply to rules of addition. Okay? Especially like this one right here. Okay, if you're multiplying these two, you can break it up. But if you're adding the items under the square root, you cannot break it up like that. Okay, so these are very common errors. The properties of multiplication do not apply to the properties of addition. Okay, you have both assignments, day 1 and day 2, on your WebAssign. If you haven't worked on those, get those finished up and turned in by the test day. If you have questions, please let me know.